Hello, today we're going to be talking about ratio tables, okay? And we're going to be completing our notes as Cornell notes, okay? So the first thing that we need to be able to talk about is what is a ratio table, okay? And a ratio table is where we take ratios and we organize them. So ratios can be organized into a ratio table, and you should be writing these down as well, where every column has a pair of numbers that make an equivalent ratio. So it's a table where each column represents an equivalent ratio. And if you recall, equivalent means equal, okay? So let's take a look at what we have. Here's an example of a word or a ratio table. So in the very first column, columns are up and down, right? Columns are up and down. We have our labels, and they tell us what two things are we comparing? Because if you recall, a ratio is a comparison of two items. In this case, we're comparing soda and juice, where the top number is our soda and the bottom number is how many juice or how much juice. Each column after that represents a ratio. So we have soda and juice, and the ratio is 1/3, 2/6, or 2 out of 6, 3 out of 9, and 5 out of 10. We know that these are all equivalent to each other because if we were to simplify them, they would simplify to the ratio of 1/3. 2/6, I divide the top and the bottom by 2, would be 1/3. 2 divided by 2 is 1. 6 divided by 2 is 3, right? So if I divide it by 2, if I divide by 3, I get 3 divided by 3 is 1. 9 divided by 3 is 3, 1/3. Here I can divide by 5. 5 divided by 5 is 1. 15 divided by 5 is 3. So they all simplify to the same number. So they are all equivalent, okay? So that's our ratio table. Now, oftentimes they start small and get bigger, but they don't always have to be in order. You'll notice that this goes up 1, 2, 3, but then it skips a ratio and goes to 5 instead. So be aware that sometimes they skip, okay? So the pattern, if you'll notice, is going up by 1 each time here until here, and then up by 3. You can also notice that to get from one ratio to the other, they've multiplied the top number and the bottom number by the same amount. It goes, so to get from 1 to 2, we did times 2. To get from 3 to 6, we did times 2. To go from 1 to 3, we multiply by times 3. 3 to 9, we would multiply by 3. Okay? So how do we make a ratio table? Right? To make a ratio table, we make equivalent ratios, which means we need to know how to make equivalent, sorry, that's a V, E-Q-U-V, I guess, equivalent. Good thing I'm not your spelling teacher. Equivalent ratios. So equivalent ratios are made by multiplying or dividing by a given ratio by the same number. So if we start out with any kind of fraction, like 1/2, if I am multiplying, right, if I do multiply, I am scaling it up, making it bigger. If I take that same fraction and I do the top and the bottom, but I divide, I would be scaling down. Okay, so we can make the ratio an equivalent ratio that's bigger or an equivalent ratio that's smaller. Okay, So to create a ratio table, we multiply or divide by the same number. Multiply or divide by the same number in the top and bottom of the row. Let's take a look. We've got a granola recipe. Honestly, granola not my favorite, but that's okay. All right, I'm going to go ahead and erase what we have. Okay, so we have a granola recipe, and our current granola recipe uses oats and almonds. So you'll notice the very first thing they did was label oats, almonds. And the ratio table that we've been given, we have a ratio of 10 cups of oats and 6 cups of almonds. So if I wanted a smaller batch, because maybe granola is not my favorite thing in the world, if I wanted to make a less of this, I could scale it down. I would divide, okay, by the top and the bottom. So I'm going to take 10 and 6, and I need a number that I can divide them both by evenly. Since they're both even numbers, 10 and 6 can both be divided by 2. So I'm going to divide 10 by 2. 10 divided by 2 would give me, that's right, 5. And then 6 divided by 2 gives me 3. So 5 and 3 is an equivalent ratio. Could we simplify that anymore? We can't. There's not a number that you can divide both of these by. But we can create equivalent ratios that are bigger by multiplying. So instead of dividing, I'm going to multiply. Now I can multiply this fraction to make it bigger, or I can multiply this ratio to make it bigger. It doesn't really matter. You can use any equivalent ratio to make another. So I'm going to use this one that we just created. I'm going to take this one and I'm going to multiply it and do times 3. Because if I multiply by 2, it gives me 10. So let's do 5 times 3 gives me 15. And I have to do the same on the top and on the bottom. What's 3 times 3? Yep, times 3 gives me 9. So another equivalent ratio would be 15 out of 9. Okay? We can do anything that we want to do, though. Like, we can use this one and then create it again. As long as we do the same thing to the top and the bottom, we'll always end up with the same equivalent ratio. Let's take this one and multiply it now by 4. So instead of 3, let's do 4. 5 times 4 is 20. 3 times 4 is 12. Okay? So to make a larger ratio, or to scale up, we multiply. And to make a smaller ratio, or to simplify our fraction, or a ratio, we divide. Divide to make it smaller. Divide to scale down. Okay, so hopefully you have that written down. I'm going to go ahead and continue. All right, so let's take a look at an example. So first thing that we need to do when we create a ratio table is figure out what two things are we comparing. Ratio, comparison of two things. It says one notebook costs $6. How much money will it cost for 5 notebooks? Okay, so the two things that we're comparing, we're interested in notebooks, right? So notebook, notebook. And the other thing that we're interested in is money, right? Money. So money, or dollars. So one notebook. I have one notebook. So for the number of notebooks for my first ratio, I'm comparing one notebook, costs $6. So I put a 6 in the bottom. So that's the ratio that I'm using. One notebook for $6. And we're trying to figure out how much money it'll cost for 5 notebooks. So this 5, it's 5 notebooks, so I know there's 5 notebooks. Now, before we learned that to make a ratio table, we had to multiply by the same number on the top and bottom. So to get from 1 to 5, first of all, did we scale up or down? Are we getting bigger or smaller? We're getting bigger, so if we're scaling up, we know we need to multiply. So we should be multiplying. What do we multiply 1 by to get to 5? 1 times 5 gives us 5. Since we did 1 times 5 on the top, we do the same thing to the bottom to create an equivalent ratio. 6 times 5 is 30. So I know that 1 notebook costs $6, 5 notebooks has to cost $30. Let's try another example where we're going to divide. All right, we have Jose who won a hot dog contest by eating 66 hot dogs in 12 minutes. That's pretty awesome. Okay, if he ate at a constant rate, determine how many hot dogs he ate in 2 minutes. All right, so we got hot dogs, which are delicious. I like hot dogs. And then we are also comparing that to how many minutes. So minutes. All right, and the numbers that we have been given are that we have 66 hot dogs in 12 minutes. So hot dogs goes in the top where I put hot dogs, 66. And then the 12 goes in the bottom where I have minutes. 66 hot dogs, 12 minutes. That's our ratio. If he ate at a constant rate, determine how many hot dogs he ate in 2 minutes. So we had minutes here and minutes here. We're putting minutes in the bottom, so I know this is compared to 2 minutes. So now we're going to use equivalent ratios to figure out how many hot dogs. We need to figure out how many hot dogs he ate in 2 minutes. To create our equivalent ratios, we scale up or scale down. So let's compare it. 12 to 2, did we get bigger or smaller? We got smaller, so we scaled down. If we're scaling down, that means we are dividing. What can I divide 12 by to give me 2? If you're not sure, try Desmos. 12 divided by 6 gives me 2. And so I also need to do dividing by 6 on the top. 66 divided by 6 would give me 11. So now that I have a second ratio, one that's equivalent to the first one, it tells me that he ate 11 hot dogs. 11 hot dogs in 2 minutes. Go ahead and try the next ones by yourself. We'll get you started on some of the information, and then you need to try the rest of it by yourself. It's really important not to just write down the part that we're doing, but also to give it a try on your own. And then if you have a question, ask the question and we'll help you out. So just to get you started, in the first one, a recipe calls for 5 cups of water for every cup of black beans, and we want to know how much water is used for 4 cups of beans. So we're comparing water, right? And we have 5 cups of water for every 1 cup of black beans. So beans, there's 1. We're trying to figure out how many cups of water should be used for 4 cups of beans. Okay, so think about where you should put that 4 and what you need to do. Okay, are you scaling up or scaling down? And the second problem, to make jam, you need 12 cups of sugar for 16 cups of cranberries. So we're comparing sugar and cranberries, and we want to find the amount of sugar needed for 4 cups of cranberries. So we have sugar and 12 cups, and for cranberries, we have 16 cups. We want to know how much sugar we need for 4 cups of cranberries. You can set the last one up all by yourself and see how you do, okay? If you have a question, make sure to raise your hand and ask. You can unpause this when the class is done and you want to check your answer.